Hi everyone, this is going to be a video of me trying to do activity 4, which I've called Dodging COVID-19. Very topical. That won't last for very long, I'm suddenly realizing. Hopefully. So as is the way with these videos, I'm just going to kind of go step by step through the activity. I'll make some mistakes, no doubt, and I'll just talk through my thinking process as I write code that meets the brief of the activity. So let's go look at the activity now. Here is the activity. The objectives are that we're going to be using variables for movement and visuals and stuff. We're going to get used to using conditionals for making decisions in our code. There's a couple of new functions in here that I wanted us to look at. One's called Dist, which stands for distance. One's called no loop, and one is called no cursor. We'll get to them when we get to them. And we're going to use a loop in our code just for fun, basically, to have a visual effect of static in the background. Okay, so what's the idea? What I want us to do is have a kind of simulation, an attempt at a sort of very basic simulation of COVID-19. So COVID-19 is going to be a red circle. It's going to come at us from the left side of the canvas. It's going to be at a random height, though, a random Y position. And every time it goes off the right-hand side, it resets back to the left side to a random Y position again. And the user, us, the person controlling the program, will control their circle with the mouse position. And if they get touched by the COVID-19 circle, the red circle, then whatever, the simulation is over because you got COVID-19 and you were trying not to. And you've got to self-isolate for 2 weeks or whatever. Hopefully it's only that. And then in the background, just for visual flair, to use a loop, we're going to see random static to simulate the anxieties around trying not to catch COVID-19. Okay? Oh, and we're not going to see the mouse cursor over the top of the canvas, just so that it looks a little bit cleaner. There's lots of different ways that we could do this. If you're feeling confident, just try and make it yourself and see what happens. If you want to follow along with me, then follow along with me. Pause the video after each step if you want to before I do it, and see if you can come up with the answer, and if you can't, you can see what I do. So, first step is to create a new project. You've seen this process many times, so I'm just going to do it fairly quickly. I download the template, I open the template, I go to the Cart253 folder on my computer, that's my repository, right? And I go to Activities. I need to also have a window open so I can see my desktop. There it is. And I have multiple template projects, as you can see. What am I going to do here? What am I going to do? I've already confused myself. I'm going to close this because I'm not working with that anymore. I'll delete these two, and I will open my zip file and copy the folder across into my repository and rename it. For Dodging COVID-19. I think I didn't put a hyphen in the suggestion. There we go. So I've got a folder. It's got the template project in it, and it's in my activities area. And I want to open it with Atom. So I need to open Atom, I guess, since it's just closed. Here's me making mistakes, just for you. And I want to open a project. Open a project. There we go. And in my Cart253 folder, I go to Activities, Dodging COVID-19, and I open that folder, right? Pow. Perfect. Okay, and let me close this other thing, because I don't really want this open right now. Lovely. So, here's my script. Again, I'm going to just delete the kind of extra stuff here. You should not do this. You should be adding comments. But I'm afraid that I don't have quite enough time to do perfect commenting in this activity. I probably should, but I'm not going to right now. Good, so we're ready. Oh, and I need to commit in GitHub Desktop. So over here, I type in A4, because it's activity 4, started dodging COVID-19. In fact, I haven't just started. I've been trying to dodge COVID-19 since it began. Commit to master, and push. Okay, we're ready to begin. So I've got my empty code. Let's find out what my first step is. So planning stage, And we know what the brief is, so here's the order that I'm going to tackle it in. I'm going to work out how to display the COVID-19 circle and have it move across the screen from left to right, starting at a random Y. That's my first step. My second step is going to be to make the COVID-19 circle reset. So once it goes off the right-hand side, and you can imagine we're going to need an if statement for that, it should go back to the left-hand side, but it should also then start at another random Y location. Once I've done that, I've kind of got the COVID-19 circle working. Then I'll work on displaying the user circle at the mouse location. I think we know how to do that. That shouldn't be too hard. The big, maybe challenging one, well, one of the big challenging ones is checking if the two circles overlap. And if they do, stopping the program from executing. There's some new stuff in there, so we'll look at that one when we come to it. And I said I wanted to display random static in the background for a visual flourish. We'll look at that. And then I want to hide the mouse cursor. Okay, we can do this. We can do this. So, part one, we need a COVID-19 circle. So, fairly clearly, I think we should just make a variable, as it says. I don't know why I'm trying to think of what to do. It's got instructions. So we're going to declare a COVID-19 variable, and it's going to have position properties, 0 and 250, okay. A size property, 100 is fine, doesn't matter. Velocity properties, so we know it's going to move. Even though it's not going to move in the y-axis, when we're using velocity, we may as well have a y velocity there anyway. We might want it to move in the y at some point. And a speed that determines how fast it moves. I've suggested 5, it could be anything. And we're going to have a fill property. Oh, and this will be interesting. So because we want to fill it red, we need the 3 numbers, right? We need the red, the green, and the blue. So we're going to look at having a fill property that has inside of it another JavaScript object that contains those properties. We'll look at what that looks like. This is a cool thing to learn. Okay, so let me make my COVID-19 circle variable. So I'll call it COVID-19, let COVID-19. This is a good instance actually of using a number in a variable name. It seems appropriate. It's better than writing it as COVID-19 or something like that. I mean, this would be fine too. But I think there's a good case to be made here for COVID-19, like that. We assign it an object. So because it's an object, we know it's going to be curly brackets, and it's going to have a series of properties, right? Which we write property name, x. For the x location, it's going to start on the left side, so 0, a comma, and then the next property name, and so forth. I said I would start y at 250. I said I would set the size to something like 100. I said it would have a velocity in the x. I'll start that at 0, and a velocity in the y, also 0, and a speed, which I suggested making 5. And I suggested we need a fill. Now, I can't write a fill of like 25500 here, even though that would be nice, because JavaScript just doesn't understand it if I write it that way. Nor can I, for example, write it like this, even though that also looks quite nice, and you might think that that would be reasonable for that to work, but it doesn't. The thing that I can do, however, is instead of having a number, if I want to have multiple numbers here, what I can use is another JavaScript object. So we know that a JavaScript object, we can tell it's a thing because it's in curly brackets. So actually a JavaScript object can be a property of another JavaScript object. So this is this idea of nesting again, which is very popular in programming. So we can see that there's the outer JavaScript object, which is COVID-19. That's what's going inside COVID-19. That's between these two curly brackets here. And then in the fill property, we've got another JavaScript object also between two curly brackets. We'll look at how we get access to these properties as well. So when we've been doing colors, we've been doing something like red. The red amount is going to be 255. The green amount is going to be 0, and the blue amount is going to be 02. You can see I'm just writing it just like we wrote the main object, right? Like any object. It's just property name, number, comma, property name, number, comma, property name, number. The difference is that now we know that any property in an object can be another object. So we can kind of have a hierarchy of information, which is great. Okay, wonderful. I believe that is everything that I said that I needed to do here. Let's set up the canvas. So, to set up the canvas, I need to make a canvas. I'm going to make it the dimensions of the window. That's a good idea. And I need to set the Y property of the COVID-19 object, so it's vertical location, to a random number between 0 and height, because we said it was going to start at a random y. And I'm going to set its velocity, its x velocity, to be its speed so that it will start moving to the right. Okay, so let's do that. So create canvas, window width, window height. So it's going to take up the whole screen. I'm going to tell COVID-19.y, so that's its y position, that's this one here. It started at 250, but I'm immediately going to change it to a random number between 0 and the height. Then it's going to start, we don't know where, somewhere between the very top of the screen, which is 0, and the very bottom of the screen, which is height. Okay. Note, I could have used window height here. You might think that that would be a good idea since you know that the height of the window is window height, but it's much, much better to use height, because if we do eventually change this at some point, if we change that, this will keep working. But if I had explicitly put window height in there, it would stop working. And we said we wanted to start moving, so we also need to tell its Vx, its velocity, and the x-axis. We need to assign that something, and what we will assign it is its convid, its speed. That's going to be 5, so it's a positive number, so we're expecting our COVID to start moving from left to right. Quite a bit to do there, but now we've got a COVID-19 object, we've got a canvas. The COVID-19 object has a random y position, so we don't know where it's going to start from, and it's going to move at its speed in the positive direction. Lovely. We're not, as I noted here, we're not going to see anything yet because we don't actually draw the circle, and nor do we move it. So let's do those things now. Draw the background, move COVID-19, draw COVID-19. Okay, so we want to have a background color, or a black if we want. I'm going to use black, so let's do that. Use background to set the background to black. We know all about that. We know that we do this sort of thing in Draw, of course. So background is going to be black. Done. Update COVID-19's x and y by adding the Vx and Vy properties. So this is the standard movement stuff that I've talked about in the past. So COVID-19.x equals COVID-19.x plus, if I can hit the right key, COVID-19.vx. That's the standard update for its x position, is that we add the velocity. We know that its velocity is the speed, and we know that the speed is 5, so we know that this is the same as adding 5 to its x position, which means it moves to the right. Even though this version of the program, it doesn't move in the y direction, it just makes sense to have this code in here anyway. It doesn't do any harm, it just adds 0 to the y position over and over, right? Because the Vy is 0, so it's not going to move, it's not going to do anything, but it's better that it's there just for completeness. Okay, so now it moves. What else are we meant to do? We need to set the fill. Okay, so this is a good moment. So we know that we want to set the fill for the COVID-19 color, and we know that its color is inside the fill property. So we know that at the very least we need to write circle.fill, because that's where the fill color is defined, but we know that the fill is another object that has its own properties, and so what we do in this instance is, I think, the most sensible thing, which is that if we know that circle is an object that has a fill property, and we write .fill to get that property, if we want to get a property inside that property, because the property is an object, we just write dot and then the next property name. So to get at this R here, we write, I'm just realizing I've written circle there like an idiot. Well, not like an idiot. Anybody could have done that. Even you could have done that, right? So COVID-19, that's this thing that has the object in it. We write .fill, if I could use my fingers, .fill to get this property inside that object. And then we write .r to get this property inside the object that's in fill. And we can do the same for the other properties. So COVID-19.fill.g, COVID-19.fill.b. So then that will use 255, 0, and 0, which is what's inside those properties. And now, of course, we could change those things if we wanted to change it to change color, for instance. Not that I'm going to do that. And then we can finally draw COVID-19 on the screen. COVID-19.x, COVID-19.y is its position, and COVID-19.size is its size. Wonderful. So if we were now to go and look at our program, hopefully, we need to run it. So I haven't run anything yet. This is quite a lot of code to write before actually running our program, but sometimes you don't actually kind of get to the stuff that makes something happen that you can see for a little while. This is not a terrible amount. This is still only one kind of screen's worth of code. So, I mean, it may be that something is wrong in here, but we'll just have to see now. So, Atom Live Server, start server. Okay, and as you can see, red COVID-19 moves from left to right across the screen. Off it goes, and as circles do, as moving things do, unless we tell it not to go off the right-hand side, it's just going to kind of keep doing what it's doing. So now it's gone. So that's the kind of the next thing that we need to get to. Notice that my entire window is black, right? Because I used window width, window height as the dimensions of my canvas, which is very satisfying, and that the circle therefore was able to move all the way across the screen. Okay. Good. So the big new behavior of COVID-19 is that when it went off the right-hand side, we wanted to reset it to the left and reset its random position. So we need an if statement that's going to check if the COVID-19's x position is greater than the width. Because if it's greater than the width, then we know it's gone off the right side. And we know that what we want to do when that happens is reset it to the left and reset its height to a new random number. So let's do that. So we need an if. Now, again, deciding where to write this if is a thing that we need to think about. My philosophy is that because what we're wanting to check depends on x, and because this is where the x changes, we should do it. This is kind of where the movement stuff happens, right? And what our if statement checks is what happens as a result of movement. The if statement should come after that, and all of the displaying stuff should be maybe here at the bottom. So if the x position of COVID-19, so COVID-19.x, that's where it is on the x-axis. If it is greater than width, which is the width of our canvas, that would mean that it has gone off the right-hand side of our canvas. So if that happens, I said what I wanted to do is I wanted to move it back to the left, so I can do that by setting its x position to 0, that's the left, and I wanted to reset its y to a random number. And I actually already did that up here, right? This line here in setup. COVID-19.y is a random number, is assigned a random number between 0 and height, so I could just copy that code and paste it in here. So now when COVID-19 ever goes past the width, it moves back to the left and it gets a random y position again. Let's go look at that happening. Off it goes, moving across, just about to reach the right-hand side, did so, and it moved to a new random y location. It was kind of a little bit similar, but there you go. That's a nice drastic one, right? So you can tell that it's jumping. Each time it moves back to the left, it's jumping to a different y location because of that random number. So now it's doing exactly what I wanted. Great. So that's the resetting. Now we want the user. So we want our user circle. This is a very, very simple one. All we want is that the user's circle is going to be drawn where the mouse is, and that's it. That is sufficiently simple that I'm just going to go and do it and not worry about the steps as much. So let's make another variable because we know we're going to want a variable to track the user. I guess you could call it victim or something like that. Vector if you wanted to. Disease vector. So it's going to be an object again, and it's going to have some similar properties to COVID-19. It's going to have a position. We can decide where we want it to default to. Could be the center of the screen. Because we're going to be controlling it with the mouse, we know that it's going to actually jump to where the mouse is. So these numbers are a little bit meaningless in that they're going to get changed. And it needs a size, let's give it 100. And it needs a fill as well. I think in the steps I said, let's just use a simple grayscale fill so that it's just white, just to avoid having to write another color object. But you could write another little color thing like this if you wanted to control the user's color. Just like with COVID-19, we want to set the user's x and y position so that it can move. In this instance, we're going to set it to be the same as the mouse. So we'll say user.x equals mousex, user.y equals mousey. So now every frame, the x position will be the same as the mouse's x position. Same thing for the y. So it's going to jump. And we need to draw the user. Again, I'm trying to kind of group my drawing stuff down here at the bottom. So here we've got the stuff that actually controls movement. We could actually say COVID-19 movement here, for example, if we wanted, and user movement here. And then we could say display COVID-19. And then we would display the user. These are not amazing comments. I'm just pointing out that this is the kind of grouping of things that I'm using here. So again, we set the fill. This time we set the fill just to user.fill because it's just a grayscale color. So that's 255, we know. And exactly the same thing for displaying. So user.x, user.y, user.size. So then we have created a variable with the basic properties x, y, and size. We set the x, y to the mouse location and fill, and we display our ellipse at that position. So if we go look at it now, we've got our little circle that is following my mouse around. Woo, woo, woo. Taunting COVID-19 is pretty slow. So it's pretty hard to get caught running circles around COVID-19. Okay, so that worked. Catching COVID-19. So this is where it gets a little bit complicated, okay? These are some new ideas in this step especially. So I want to just go through this and make sure that I try and explain it as well as I can. So the big kind of interactive moment that's new in this program is that I want to know if the COVID-19 circle touches the user's circle. Because in the simulation, right, the idea is that you would catch COVID-19 if COVID-19 touches you. And what I want to do when that happens is I want the simulation to stop. So everything just is over. That's kind of the end point of the simulation. So clearly I'm going to need an if statement that checks, is the COVID-19 circle touching the user circle, right? I need to say, if the COVID-19 circle is touching the user circle, then stop the simulation. But the programming, sort of the language for us to do this is going to be something that we haven't explicitly seen yet. But you could try and do this on your own first to start with. So the thing that I'm going to end up using is a function called dist. And I've got a link to its documentation here, which I'll open up. So the dist function, if we go and take a look at it, is perfect for what we need, because what it does is it tells us the distance between 2 points. And that's really what I'm asking when I'm asking if the COVID-19 circle touches the user circle. I'm really asking whether it's within a certain distance of that user circle. So let's go take a quick look at the documentation. Oh, that's very nice. So you can see, actually, this is a very nice little example. You can see as I move my mouse around on this little line, it's telling me how long that line is, right? So here it's 108 pixels long. Here it's 27 pixels long. And the thing that is telling this program how long that line is dist, which is right here. Okay, so dist, let's go look at its syntax down here, works like this. You say dist, D-I-S-T, they were too cheap to call it distance, and you give it the first point, x1 and y1, and the second point, x2 and y2, and it will tell you the distance in pixels between those 2 points, right? And that's what we want to know. How far is COVID-19 from the user at any given moment? So let's first of all take that step. So after all of the movement has taken place, so COVID-19 has moved and the user has moved, this is where let's check for catching COVID-19. So the first thing that I want to do is I want to know the distance between COVID-19 and the user, or between the user and COVID-19, depending on how you think about it. And I want to store that piece of information, that number, inside a variable. So I'm going to call the variable d. You could call it distance or something else. I'm calling it d. It's just sort of, it's an efficiency. And notice that I'm declaring this d variable here, right? I'm not declaring it at the top. I'm not saying let d up here. I'm saying let d here. And the reason for that is because this is a variable that I only need just for this one moment, right? I just want to calculate the distance. I need somewhere to put it, and then I'm going to immediately use it, and then I don't need it again. This is an instance where it's a good idea to declare a variable just right where you need it, because you're not going to need it later on. You can recalculate it on the next frame. So let d is assigned. We're going to use our dist function, and we're going to give it what? The position of the user. Where is the user? The user is at user.x, user.y. So that's the first point in space that I want to check. And I want to check how far that point is away from COVID-19's position, COVID-19.x, COVID-19.y. So what dist will do for me is it will take these two positions and using some nice geometry mathematics, it will calculate the distance in pixels between this point and this point, and it will give me back the answer, which I will store into D. You can probably guess, if you have done a little bit of geometry, that the magical mathematics that it uses here is the Pythagorean theorem, right? The way that you calculate the length of the hypotenuse of a triangle. Let's not get into it. So after this line, D contains the distance in pixels between the user's position and the COVID position. The next thing I then need to do is I need to ask, is that distance sufficiently small that they must be touching each other? And this is another little piece of maths. This maybe is something more to memorize than for me to go into too much depth. We know that if we're going to check if this distance is within a particular distance, if it's small enough, we're going to need to use a conditional. So we're going to have to say if. And then in here, what do we ask? Well, we know that we're going to be checking the distance. And we know that what we are going to care about is if those 2 points, the user and the COVID-19 circle, get very, very close to each other, right? Now, if I wanted to know that they were exactly on top of each other, I could just check if the distance was equal to 0, right? If they are occupying exactly the same position, the 2 centers of the circles are overlapping perfectly, then the distance between them is 0, and I would know that they were perfectly overlapping. That would be a way to go, but clearly it's not going to be that satisfying because that's a really, really specific case. It's only if their 2 centers are perfectly overlapping. That might even be quite difficult to make happen. So what we really want to do is check if the distance is less than some kind of maximum amount. And the way that we can do this, thanks to geometry, is that we know the size of each circle, right? We know that COVID-19 is 100 and user is 100. So if, for example, we said if the distance is less than their 2 sizes added together, so COVID-19.size plus user.size, that would start to be an approximation of the correct distance, because it's at least now the distance we're saying, is it relative to their sizes? Is it less than their 2 sizes added together? But the correct math is that we actually want the radius of each circle. So COVID-19's size is really the diameter of the circle that we're drawing. Dividing it by 2 gives us the radius, which is the distance from the center of that circle to the edge. And if we add the radius of COVID-19 and the radius of the user size, it turns out that if the distance is less than those 2 things added together, we know that the 2 circles are touching or overlapping in some way. That's how the math works out, okay? This is something that you may intuitively understand, or you can memorize it. And if you really, really, really want to know, then I can talk to you and we can draw some circles with lines and stuff and prove that this is true. Otherwise, it's perfectly reasonable to take this on faith. So if the distance between the 2 circles is less than the radius of each circle added together, which means that they're touching, then what do we want to do? We want to stop the program. Now, this is another moment where we need a new function. I gave the name of the function in the activity instructions. There is a function called noLoop. Looks just like this, and what it is saying is stop the draw loop, basically. Like at this exact moment, no longer bother drawing anything. Don't keep calling the draw loop. The frame rate stops, the movie stops on this frame. So that's the way that we can say the game is, the simulation, sorry, I slipped. The simulation is finished because we caught COVID-19. And that's what we needed in order to have that happen. So let's go check that out. We'll go back to our project. So here's my mouse. You see there's 2 circles touched each other there. You can see there's a slight overlap. That means that the distance is less than their 2 radiuses added together, which means that they're touching, and the program has stopped. I can no longer control anything. To start the program again, I need to reload the window. And again, now I can sort of dodge. I can try and daringly run my circles around COVID-19. Ha, 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 ha. But as soon as it touches, then no loop is called because the distance is less than their 2 radiuses, and the program stops. So we get a kind of an end point. Okay, so that is how we are going to achieve that step. Perfect, we've done that. The final thing that I wanted to do, just to sort of, because we were hearing about loops recently and I wanted to have a loop in there, is I wanted to see static in the background. I'm trying to pretend that it's about anxiety. Really, I just want a reason to use a loop. So one way that we can make static appear is that we can draw lots of points on the screen, the shape point, which is just a dot, right? If we draw points on the screen at random locations, then we'll end up with like just a whole lot of points all over the screen. And if we do that every frame over and over again, because they're going to keep changing position, what you end up with is them kind of sparkling or creating a kind of static effect. And to do that, what we're effectively saying is every frame I want to draw some number of points at random locations, And this is exactly the kind of situation where we would use a loop, because we're wanting to count. We're going to want to do some specific thing a set number of times by counting up to a number. Okay? So because this is kind of a background effect, we're going to do it just after our background instruction. And we're going to use a for loop. I'm just going to talk, again, I'm just going to kind of talk through this. So we want to do this here. Display static, let's say. And what we want to do is, we know how to display one point in a random location, right? So let's say we want to do that. So we're going to have an x where we want to display it. Again, notice how I'm using let x here, because this is just a thing that I'm going to use once and then throw away. So a random x position would be like this, right? X is a random number between 0 and width. Same thing for y, random number between 0 and height. And then I could draw a point at that position. I think I would have to set the stroke color to be white, or we're not going to see it. And then I could draw a point at x and y. Perfect. So this means that every frame, I'm going to draw one point at a random position. So let x equals a random number between 0 and width. Let y assigned a random number between 0 and height. So x and y are some random position on my canvas. Set the stroke to be white. And then draw a point at the location that I just generated. Now, if we go and look at that, I don't even know if you can kind of, I can see it. It might be a little hard to see at the resolution of the video, but there's a little white point moving around. Well, there you go, it's there now. The program ended and that's where it ended up, just above my cursor there. It's not very impressive because we're only drawing one point every frame. So what we really want to do is do that, say, 100 times every frame or 1,000 times every frame. And for that, what we need is a loop. So what we want is to do this thing, say 100 or 1,000 times, and to do that, we can wrap it inside a for loop. So let's write a for loop. So for, now the traditional way that we write a for loop is we say let I, it doesn't have to be I, but I is a classic, is assigned 0. We almost always start at 0. And I is less than, and then here we put the number that we want to count up to. So I'm going to count up to 100 in this instance. So I want 100 pieces of static. And then the classic extra thing is I should go up by 1 every time. And then inside the curly brackets of the for loop, the block of code, I want to paste in that code that I was just writing there. So now, rather than this happening once, causing a single point to move around on the screen, it's going to happen 100 times because the for loop is going to count up to 100, drawing a random point 100 times, and it's going to do that in one frame so that there's going to be 100 points all at once on the screen in one frame, and then the next frame, same thing is going to happen. There's going to be 100 points in random positions on the screen, and that's going to keep happening, so we're going to get a kind of a sparkling effect. Let's go and make sure that that works. Again, depends a little bit on how visible this is to you with the video quality, but I am now seeing a little sparkle of points, and if I cause the program to stop, there's like a little kind of constellation of stars all over the screen now. So 100 doesn't seem like it's enough, so I'm going to increase it to 1,000 and go back, and now that's starting to be pleasingly anxiety-inducing. Now it sort of feels like a more intense environment. Again, if I get caught, we can see the random position of all of the points, like a star field now, because the program has stopped and the for loop ran for its final time, and this is the random positions that it chose for all of those random points. So just to quickly go back and look at that code, this is another example where I'm declaring my variable here instead of at the top, and again, the reason for that is that I want a random x and a y, but then I'm immediately going to use them, and this is the only place I'm going to use that x and y is to draw this point. And so there's no real need for me to make these variables all the way at the top of the program with that kind of special status of things that I need to know about all the time. Instead, they're just variables that I just want just for this little sequence of actions, which is selecting a random location and then drawing a point there. Come back around the for loop, select another random location and draw a point there. This is a very common thing that you'll see. It's a good thing to get used to is if your variable, if you only need it for this one moment and you don't need to keep track of it over time, then declare your variable right where you need it. If you need to keep track of it all the time, as we do with COVID-19 and user, right, because these have things that are relevant while the program is running, then we probably want to declare them up here at the top. Okay, so we've got our static. I believe that that takes us to the end of the program, right? Have a look and change the number of pieces of static and see what happens. I think that you'll notice that as you use bigger and bigger numbers, your program is going to slow down. And that's because just even though, you know, it's a program and computers are fast, there's a limit to how much you can try and do in a single frame of animation. Because remember, it's drawing, say, all 1,000, all 10,000 of these pieces of static within one frame. So it's trying to do it in a 60th of a second, and computers have limits. Oh, and as I point out here, and this is very true, we probably want a variable for our static amount. So back over here, rather than 1,000, which is a hard-coded number we want to avoid, let's have something like num static. And let's declare that at the top. Let num static equals, I'll try 5,000. So just to keep things tidy, it's much easier to kind of change the most important things in my program up the top if I move this up here. And then it's going to count up to num static, which is 5,000. Let's go see what that looks like quickly. Oh, it's even more staticky. Kind of feels a tiny bit more sluggish now. So we can see that maybe it's sort of starting to hit a limit of performance, at least on my computer. Okay, there's probably more stuff that could be done, but I think that that was a good pass through the activity. We learned some new stuff. I'm realizing as I say this that I said that we were going to remove the cursor, and I did not actually do that. So here in the video I'm going to do it, even though in the instructions that I'm looking at it's not there, and I will put them into the instructions. So let's do one last thing, which is, and this is it's really very simple. There is just a function called no cursor. It's literally as simple as this. So you write no cursor, note the big C again. We'll do it in setup because it's just something that we want to apply to the program for the rest of the program running. And by putting that in, no cursor, let's go back across and reload. You can see now that you can't see my cursor. I mean, it does what it says it will do. And this is just nice because it makes it feel a little bit more immersive, if you like. It's not that sort of extra piece of user interface kind of hanging over the program. Perfect. Okay. That is it, I believe, for Activity 4. Thank you for coming along on this journey with me if you did. And if you didn't, then you're not listening to me right now, so it doesn't matter. So thank you very much, person who is listening to me. I will see you in another video at another time, and I will be just as happy to see you then as I am now. So, bye for now.